Good afternoon, I am Rosangelica Martinez Lopez. I am from the University of the Americas, Puebla. Well, I will start. This project consists on the investigation of different electronic components and design of a photovoltaic system in order to use it with the design of controller system of photovoltaic one to achieve a device according with the specification of the UDLAP Christmas tree. We continue with the objective and goals. For this project, the principal objective is the development of a photovoltaic system, making all the steps in order to reach our goals. We need to make the design, the consideration, the simulation, and finally the relation of the complete device. The goal to achieve is the use of our knowledge in the solar energy and the investigation of how to develop this for energy. Another is design and develop or design an existent solar panel and correction application of a controller system to reach the necessary amount of energy. Using this, the energy from the photovoltaic system to make a solar system capable to supply the ultra-Christmas tree and reduce the electric bill and energy waste. We continue with the specifications. The relation of this project focuses on the power part, the controller, and knowing the photovoltaic system and thinking about the implementation physical. That was the goal from the beginning. But we start with the investigation of part of the power system. It constrains on obtaining information and operating of different converters such as DC to DC or DC to AC, as well as isolating converters. And with this, it will continue with the selection of the converter that will be used in the moment of the physical implementation of the project, continuing with the controller system. The investigation focuses on the controller system for a power source. And finally, I focus on the photovoltaic system, beginning the investigation with the parts of an insulated photovoltaic system, and one interconnected with electrical grid. Brief describing each system and its applications. That was my part. In the part of development, we have the parts of the photovoltaic system interconnected to the electrical network with ECFE. Like you can see in the screen, we have the photovoltaic system generator with continues with a power conditional subsystem interface with the network, and finally what is the local power supply. Also, we have a control and monitoring subsystem. Starting with the photovoltaic circuit arranged made of several branches of photovoltaic modules connected in parallel. Continuing with the photovoltaic cells, which is the semiconductor element capable of convert sunlight into electrical energy via direct current. Another part mentioned about is the power electronic devices. Interval whose main function is to the converter to DC signal of the GFB, that is the generator photovoltaic system, in a seed signal, synchronizing with the network. It is the photovoltaic system interconnected with the grid. Photovoltaic system, the electricity generator is the which the direct current energy from the GFB is converted into alternative current energy. The power conditioner subsystem. It is the subsystem that converts energy into the DC from the GFB in an AC energy compatible with the energy requirement. This conversion is carried out by an inverter, and the subsystem can be made up of one or more inverters. With the part of the results, we did a simulation in Simscape with Simulink to observe the operation of a solar cell, obtaining it in the characteristic curve of current, power, and voltage. 60 solar cells were placed in the simulation to considering that in a solar panel. We used Simulink blocks like the product ramp and scope, like you see in the screen, and other Simscape blocks, like a constant, the solar cells, and the current sensor and a current voltage source. So we need to put it a converter to Simscape to Simulink and Simulink to Simscape, and a block configuration to solve the Simscape conversion problems. It's only for that. Okay, we continue with the Simscape constant block will be considered as the irradiance of the sun. The product between the current and the voltage will give us the result of the power. And in the scope we can observe the voltage, power and current. Observing the power curve, at the point of maximum power we have a value of 140.6 watts, which was at 36.5 seconds. When compared to the current, it is a value of the same time as the maximum power was 4.6 ampere and the maximum voltage was 30.4 voltage. Conclusion: the solar system will support a big amount of energy to supply the UDLAP Christmas tree, that helping the university to reduce maybe only a little bit the electrical bill, and also being environment friendly. Maybe this is the start to being more friendly environmentally in the university. In this work, we also apply all of our knowledge acquired during the career, and we applied it to the photovoltaic system to investigation from the characteristic requirement from the UDLAP Christmas tree.